85% of Earth's biomass takes root where opportunity meets sunlight. To a plant, the life-giving sun can be a challenge of extremes, bright and unyielding, then suddenly absent. The pendulum swings, day by day, hour by hour, from 1 second to the next. In an underground lab at MIT beyond the sun's reach, Gabriela Schlau-Cohen is revealing how plants endure the changing sun, and in the process, how humanity might endure the challenges of a changing Earth.
So I grew up in suburban Philadelphia. Originally, I wanted to be an actress.
Those aspirations would not survive Lower Merion High School chemistry, where Schlau-Cohen's teacher introduced her to a mystifying reality of quantum physics, that an object can be both a ball and a wave.
I found that so fascinating because it was this idea that in the microscopic world, things are so different from what we see and experience in the macroscopic world.
She traded stage life for lab life, where she'd eventually home in on the molecular mysteries of photosynthesis.
The machinery of photosynthesis is wildly complex, like this Rube Goldberg machine. A packet of light enters the leaf, setting off an energetic reaction that eventually produces sugar. Insufficient sunlight starves the plant, but too much sun overtaxes the machinery, killing the plant.
Scientists knew that plants release protective sunscreens that toggle photosynthesis on and off with the changing sun, but no one understood how. The first steps of photosynthesis happen too quickly to see.
I mean, on the femtosecond timescale, the millionth of a billionth of a second. So if we want to study something that fast, we need something even faster.
Turning some of the fastest pulsing lasers in existence onto the molecular engines of photosynthesis, Schlau-Cohen found the very proteins responsible for the sunscreen trigger. Suddenly, agricultural researchers around the world were paying attention.
One of the biggest challenges facing us as a society is the fact that there's a growing mismatch between the food that we need and the food that we're producing.
Scientists predict that by 2050, world agriculture will fall short of meeting the rising demand for food, circumstances driven by population growth and climate change.
One major revelation derived from Schlau-Cohen's work is that plants may be a little too cautious with sunscreens. Some research shows that modifying the sunscreen switch in crops, making photosynthesis more active, leads to greater yields.
The technique is inspired by Schlau-Cohen's work, and if perfected and widely adopted, projections suggest a potential food surplus significant enough to avert the shortfall, ensuring the basic needs of humanity for generations to come.
I think I'm someone who's really passionate about what I do, like a lot of what I do. I'm passionate about science, I'm passionate about learning about the world, I'm passionate about being a mom, being a friend, being a partner, care a lot about what I do and about the world around me. And I think that's a lot of what motivates me to keep going and work on what I really care about.